Good day everyone, I am Cecil D. Sempron and I will be the host for the topic of solar tower systems. Now, what are solar tower systems? Solar tower systems are also known as central towers or heliostat power plants. They are a type of solar furnace that uses a tall tower to collect concentrated sunlight. These systems employ an array of movable mirrors called heliostats, which reflect and focus the sun's rays onto a central collector tower. The concentrated solar energy is then converted into heat and used to generate electricity through concentrating solar power technology. These power plants are typically built in arid regions with high solar irradiance, such as deserts, to maximize energy efficiency. Modern designs incorporate advanced tracking systems and computer algorithms that precisely adjust the mirror's angles throughout the day, ensuring optimal sunlight reflection and continuous power generation. What are the components of a solar tower? Well, the first are heliostats. These are large arrays of mirrors mounted on dual-axis trackers that follow the movement of the sun throughout the day. Their purpose is to reflect and concentrate sunlight onto the receiver located at the top of the central tower. Next, we have the central tower. This is the tall structure that holds the receiver at its peak, allowing it to capture the focused solar energy from the surrounding heliostats. Next, we have the receiver. Positioned at the top of the tower, the receiver contains tubes or panels through which a heat transfer fluid circulates. It absorbs the concentrated solar radiation reflected by the heliostats, heating the fluid inside. Next, we have the heat transfer fluid, the medium that carries the absorbed heat through the system. Common options include molten salt, water, or air, depending on the design of the power plant. In the following, we have the thermal storage systems. This component stores excess heat collected from the fluid, usually in large insulated tanks. The stored energy can then be used to generate electricity during nighttime or cloudy conditions. And lastly, we have the power block, the section of the plant responsible for converting heat into electricity. If the fluid is water or steam, it drives a steam turbine connected to a generator following the Rankine cycle. If air is used, it powers a gas turbine following the Brayton cycle. How does a solar tower system work? A solar power tower serves as a key element in a solar power plant. Positioned at the top, at the center of a vast field of mirrors, these mirrors, usually flat and sun tracking for cost efficiency, reflect sunlight towards the tower. The concentrated rays are directed onto a specific point at the top of the tower called the receiver, which contains a fluid that absorbs the heat. This heated fluid then transfers the energy to water, turning it into steam. While earlier systems used steam directly as the heat transfer medium, modern designs employ molten salts because they can store and transfer heat more effectively. The generated steam drives a turbine, producing electricity in much the same way as conventional power plants do. With that said, I will now be showing a visual demonstration of how a solar tower works. First, we choose an area that is rich in sunlight, preferably a desert or a place that gets 300 sunny days a year. The heliostat first gets energy from the sun in the form of sunlight. That said energy is then directed towards the receiver on top of the central tower. The heat transfer fluid, which in this case, molten salt, then gets heated from the transferred energy. The fluid is then flowed down into the thermal storage system, which can be used later or during the process. The molten salt will now be transferred into the steam generator, which will heat up the water and produce steam. The said steam will flow into the power block, or in this case, a turbo generator, which will be then used to produce electricity. The steam will flow back into the steam generator, and the molten salt, which has been now cooled significantly, will be placed into another storage container, which will be used again or later. The cooled molten salt will now flow back into the receiver, completing the cycle. And for those that doesn't know what a solar tower looks like, this is it. As you can see, these are the heliostats and the receiver on top of the central tower. And both of these are the cold and hot thermal storage systems. With that said, I will now passing this presentation to my handsome and wonderful classmate, Janius Kapunitan. Thank you.
Good day everyone, and I am Janius Rubin Kapunitan, and today I'm going to discuss about heat transfer in solar tower systems. Here are the main heat transfer mechanisms. So may mga mechanisms from heat transfer. So first is radiation, solar to receiver. So sunlight or solar radiation from heliostats is focused on the receiver surface. So type radiative heat transfer surface. The effect would be surface temperature of the receiver can reach 600 to 1200 degrees Celsius depending on the design. B. Conduction, receiver to fluid walls mechanism. The absorbed solar energy heats the receiver's surface. Heat conducts through the receiver wall material, metal or ceramic. Type, conductive heat transfer. So, one equation niya, this is its equation. Q is equal to negative K dt over dx, where Q is heat flux, K is thermal conductivity, and dt over dx is temperature gradient. Main heat transfer mechanisms. C, the third one, convection or receiver wall to heat transfer fluid. So inside the receiver, a heat transfer fluid like molten salt, air, or liquid material flows and pick up heat by convection, convective heat transfer. So here is the equation. Q is equal to HA ds minus df, where H is convective heat transfer coefficient, A is equal to area, and T is surface temperature, and df is fluid temperature. So thermal energy conversion. The hot fluid is sent to a heat exchanger or a steam generator to produce steam, which drives a turbine into electricity. So some systems also store excess heat in the thermal energy storage tanks, often molten salt, for power generation during nighttime. So na po yung mga storage tanks na mo-store og excess heat para kanang kung gabi walay init. So nga gihapoy kuan. So overall heat transfer chain. Sunlight to radiation to receiver surface. So in the day, and to heat transfer, overall heat transfer chain. So sunlight to receiver surface, to heat transfer fluids, steam cycle, to turbine, to electricity, into electricity. So man siya overall niya nga heat transfer chain ang giyon sa. So from sunlight to receiver surface to ibalhin ang heat sa fluid, then steam cycle, turbine, then mahimo na siyang electricity. So how does it generate electricity at night? So yun sa saan niya pag-generate o walay sunlight since it's nighttime. So through thermal energy storage system, the key to night operation is money test using molten salts. How it works. So during daytime charging phase, so napatay source of sunlight, the heliostats focus sunlight on the receiver. Then the receiver heats a working fluid or the heat transfer fluid, typically molten salt. So molten salt ang gamit sa thermal energy storage. Then the hot molten salt, 500 to 600 degrees Celsius, is pumped into hot storage tank. So ibutan na siya sa hot storage tank. So during nighttime charging phase, when the sun sets, the hot molten salt from the tank is circulated through heat exchanger, where it transfers heat to water. This produces steam, which drives a steam turbine connected to an electric generator. The same way a conventional power plant works. So mo to ang katong na heatan mo tong molten salt, then kanang from the storage tank, then i-circulate siya from heat exchanger mo to mainit ang tubig. Then pagka init sa tubig, mag-produce yung steam kay init sa tubig. Then ang katong steam motoy mo trigger sa steam turbine. And then, ang katong steam turbine connected siya sa electric generator, which ang electric generator mo na siya mo convert into mechanical energy to electric energy. So that's how it produces electricity. So after transferring heat, the now cooler molten salt returns to a cold storage tank ready to be reheated the next day. So here are the energy flow summary. So sunlight padung sa receiver, then ipainit siya sa iinit ang molten salt, and then ibutang sa hot tank, and then kuan siya sa heat exchanger. So moinit ang tubig, mo produce og steam. So ato siya steam turbine, then connected siya sa generator to to convert mechanical energy to electricity. So here are the environmental benefits and economic advantages of solar tower system. So maka-benefit po ta ani nga system through environment. So environmental benefits. So first, clean and renewable energy sources. So hinlo siya and renewable pa ang energy. It uses sunlight which is abundant and renewable. So magamit siya sunlight no, which is kanang unlimited ang sources. So renewable. Produces no greenhouse gas emission during operation. So wala siya waste, like kanang waste na pollution. Helps reduce dependence on fossil fuels. So kanang makatabang na siya nga reduce og paggamit ng mga fossil fuels, which is makadaot sa atong kaan. Reduce air pollution. So muna no, well dili siya maka-produce og pollution. No combustion process. So no emission of mga kanang mga nga compounds nga or matter nga kanang makadaot sa atong environment. Improves air quality and reduces health risks compared to coal or gas plants. So it improves sa atong air and dili kanang ma-reduce ang mga health risks since kanang dili nag-reduce siya kanang dili siya maka-produce o makadaot. So lower carbon footprint. So life cycle carbon dioxide emissions are much lower than conventional power plants. One large solar tower system can offset hundreds of thousands of tons of carbon dioxide per year. So ang kanang dako daw nga large solar tower system instead nga mo produce og ang uban nga electricity mo hundreds of thousands, but kani siya makaless siya hundreds of thousands of carbon dioxides per year ang kaninga system. Efficient land use. So uses land mainly for mirrors, heliostats, which can be placed on non-arable or desert land. The central tower design requires less space compared to the other solar technologies for the same output. 5. Thermal energy storage reduce energy waste. So the ability to store heat allows generation at night, maximizing solar energy use. So reduces need for backup fossil fuel power, further cutting emissions. So maka-save og energy, like dili ma-waste ang energy nga sobra kay tungod sa thermal energy storage. 6. Water use reduction. So system can use air cooling instead of water cooling, reducing water consumption in arid regions. So na may mga lugar nga less of water bitaw like desert, so pwede po dili na magamit og water and kanang mag-use rag air cooling. 7. Biodiversity considerations. So when properly sited away from sensitive habitats, solar towers have minimal long-term ecological impact. So here are the economic advantages of solar tower systems. So lower operating costs. After construction, sunlight is free and maintenance costs relatively low. So no fuel purchase or transport costs. Job creation. Creates employment in manufacturing, construction, maintenance, and operation. Also generates local economic growth in installation regions. 3. Energy independence. Reduce reliance on imported fuels, improving national energy security. Stabilizes energy prices since sunlight isn't subjected to global market fluctuations. So, fourth is long-term cost stability. With high initial investment, but low lifetime costs due to free solar input. Levelized cost of electricity becomes competitive as technology improves and scales. Scalability and hybrid integration. It can be integrated with thermal storage or hybridized with gas or biomass plants to ensure reliability. Increases economic value by providing dispatchable or non-demand renewable power. Potential for export and innovation. Countries investing in solar tower system can develop expertise, export technology, and attract investors. Drives innovation in materials, control systems, and energy storage technologies. So that's all for today, and thank you.
Moving on, we have solar fuels. So solar fuels are fuels made from common substances like water and carbon dioxide using the energy of sunlight. There is vast energy in sunlight striking the earth but is dispersed and it varies over time, making it challenging to harness sunlight for practical use. So solar fuels could be an abundant supply of sustainable, storable, and portable energy. These fuels can be liquids or gases and can be used for power generation, heating, or transportation even when the sun is not shining. So solar fuel versus solar power. Although they both came from sunlight, the two differs in how they are used. So solar power directly turns sunlight into electricity using panels. So solar power is an immediate energy form used for electrical devices and as well as power grids. In short, ang solar power is ang straight to the point nga pag-convert sa sunlight into electricity. Then we have solar fuels, which uses sunlight to make chemical fuels that can be stored and used later on. So kani siya is after it convert na siya new form or in ang katong newly formed substance which is ang fuel mo i-consume and gamiton later on. Then next we have importance of solar fuels. So we all know nga ang non-renewable energy like coal, oil, and natural gas produces concerning amount of carbon dioxide and other gases nga makapagrabe sa atong makapagrabe pa sa global warming and climate change nga atong na feel right now. And this is one of the reason nga nung solar fuels are important sa renewable energy. Other than that, solar fuels also allow storage or solar energy in a chemical form for later use. They are also compatible with existing infrastructure and they are easier to transport and store compared to electricity. Then, solar fuels are also they can decarbonize sectors like aviation, shipping, and heavy industry, areas that are difficult to power with electricity alone. And lastly, it helps reduce greenhouse gas emissions and promotes energy independence. So, moving on sa ilang production methods, we have two ways which are the indirect processes and the direct processes. Under the indirect processes, we have photovoltaic and electrolyzer system, which is where electricity is initially generated by photovoltaic solar cells when sunlight strikes their surface. This electricity is then directed to an electrolyzer, a device designed to split water or H2O into its constituent elements, hydrogen and oxygen gases. So the resulting hydrogen can be stored for later use as a clean energy source while the oxygen is released into the atmosphere. So this process enables the conversion of solar energy into storable, transportable hydrogen fuel, supporting renewable energy integration and reducing reliance on fossil fuels. So next we have biomass process. So in biomass, understandable man sad siguro from the word itself na bio, which came from the Greek word bios nga meaning life. Well, biomass energy comes from growing plants, trees, or organisms that can be turned into fuel. These organisms are harvested and processed to create fuels like bioethanol, biodiesel, or biogas. So, because plants can be regrown, biomass is a renewable energy source. So, using it, it can also help reduce pollution and greenhouse gas emissions compared to fossil fuels. Next, we have the direct processes. We have thermal thermochemical cycles, which are processes that uses a very high temperatures, mostly above 1000 degrees Celsius, to split water into hydrogen and oxygen. So it is a system of mirrors focuses sunlight onto a solar tower, heating a reaction chamber where the splitting happens. So basically, most production methods, of course, production methods sa solar fuel is it involves splitting just sa water into each elements, which are the hydrogen and oxygen. And then the oxygen being released in the atmosphere while the hydrogen is being stored for later on, like para sa fuel and stuff. Lastly, we have artificial photosynthesis, which mimics the natural photosynthesis that occurs in plants but uses engineered materials and devices to capture sunlight. So, we have the fake leaf. Ah, no, not we have the fake leaf. Mura taog. So, artificial photosynthesis is like um, performing photosynthesis ra gud pod, but instead nga sa natural leaf, diba, is it produces kanang food. Ani, we have the artificial or like the fake leaf that produces or that makes the fuel instead nga katong food. So, the energy from sunlight is harnessed to split water molecules into oxygen and electrons again. And then, ang electrons along with protons generated from the water are then used in a catalytic process to convert carbon dioxide into useful fuels such as hydrogen gas or energy-rich alcohols like methanol. So artificial photosynthesis is a promising approach for directly transforming solar energy into storable chemical fuels. So potentially, this this will reduce greenhouse gas concentrations and will provide a sustainable alternative to fossil fuels. So of course, ang goal mo dyan sa solar fuel is to provide an alternative nga sustainable alternative sa mga fossil fuels, which again causes harmful effects not just atong not just most especially sa atong environment, as well as it also has its negative effects sa global warming and sa climate change. So lastly, we have the applications and benefits of consuming solar fuels. So solar fuels are applicable in industrial processes, transportation, and the production of storable, transportable fuels that serve as alternatives to fossil fuels. So first advantage of solar fuels is again reducing greenhouse gas emissions and enhancing energy independence and potential long-term cost savings. These fuels are generated by utilizing solar energy to convert fundamental substances such as water and carbon dioxide into clean, energy-dense fuels like hydrogen or synthetic hydrocarbons. So this approach offers an environmentally sustainable alternative to conventional fuels. Again, so balik-balik na dyan siya, no, nga ang solar fuels, ang main goal niya is to create a sustainable alternative sa mga usual fuel nga atong ginagamit karon, which we know nga harmful due sa atong environment. So this contributes to the greater security and sustainability of future energy supplies. So key benefits of solar fuels includes compatible with existing engines, refineries, and pipelines, and it is expected to be cost competitive by 2033, scalable to meet global energy demand, emits a far less CO2 and pollutants than fossil fuels, It also reduces dependency on non-renewable resources. Then, providing a clean, renewable, and sustainable energy source. And lastly, NAPAD supports a circular carbon economy by recycling carbon dioxide or CO2, which is also very nice kaya instead nga i-release siya again sa atmosphere na mag-cause og harm effects sa atong environment is i-recycle na noon ang carbon dioxide. So, to conclude, solar fuels are one of the most promising ways to make renewable energy storable, portable, and practical. They combine sunlight with water or carbon dioxide to create a much clean fuels that can power cars, planes, and even factories, all while reducing pollution and protecting our planet. So, instead nga ang exhaust sa atong mga transportation, sa mga planes, sa mga factories is smoke, kung ano yun nun siya, more like water vapor since it is, let's say, nga hydrogen gas siya. So that wraps up our topic, and this has been Group 9. Thank you everyone for listening.